about drawing this on our sheet, on your sheet of paper. So here we have our three-dimensional object. When you're starting your orthographic views, you can start off by just drawing in a ground line, or a baseline here, and that's known as the XY line. So that's just going to be our starting base point. We want to start off, in this case, drawing in our elevation, and generally speaking, start off by drawing in the view where it best gives an idea of the shape of the object. So this shape here of this object is generally like an L shape on its side, so we're going to look straight in at the red surface here to get that idea. So we have our direction, we have our plane, so that's our vertical plane, and we're going to project each of our edges back parallel with our direction onto the plane, giving us our front elevation. So on our image here, there's our plane just shaded in. You don't need to draw that, but just to represent it. And from our dimensions in the question, we're able to draw our front elevation. Same thing applies then when it comes to our plan view. We're looking from above this time, and we're going to have our horizontal plane that we're going to project onto. Now I'm just going to turn the transparency on this so we can see what's going on. We're going to again project our image down onto the horizontal plane. So there it is in 3D. Here it is in 2D here. So there's our plan view on our horizontal plane, and what happens is that plane gets hinged back, and there's the image been hinged back as well, so that it's flat on our sheet. So what we're going to do is we're going to literally hinge this here. So here's our ground, so this is our plane seen looking straight in at it. We're going to hinge that down, so our lines just appear to continue straight down here. For our plan view here, it doesn't really matter how far it is away from this vertical plane to start with, so I'm going to just make that maybe 20 millimeters just for convenience. So there is our plan view drawn in. So our plan view completed, we can go on and we can draw in our end view. So looking in from the left hand side here, our plane is going to appear on the right hand side, the far side of the object. So just remember that when you look in from the left hand side of the object, the image that we're going to draw is going to appear on the right hand side. So there is our plane in 3D. Here it is in 2 dimensions. So, and this is what's known as the YY line. And just a quick look at that. The line here from here down to here represents this edge here, from the top corner here down to the ground, and from here to here represents from our edge here of our plane looking from above. So even though it's one line, it actually represents 2 different parts of that same plane. So as before, we're going to project all our surfaces back in line with our viewing direction, giving us our end elevation or end view, and we're going to hinge that. So here it is in 2D, being projected onto the plane. Here it is in plan, been projected onto the plane. So next we're going to hinge our plane back, same with our image, and that's our flattened out, unfolded representation. So we're going to repeat that process. So each of these lines going back in elevation are going to appear to move straight across, and in plan view we're going to have this arc here, and the center point for our arc is going to be on this join between our YY line and our XY line. So you can see there is our image been folded out, and we take them up here like that. So this is what we mean by connected views. We don't have to remeasure these pieces here. All the heights have been gotten from our elevation, and all the widths have been transferred across from our plan view. So this view here, our end view, is actually connected to our 2 views, and that's one of the great advantages of orthographic projection. So that's our image been hinged out, and there we are having our end view. Same thing applies then